Hi everyone, in the last sessions we have discussed linked list. It's a non-linear data structure and we are seeing various operations on a linked list. And we also discussed about another type of data structure, that is a stack. What do you mean by stack and what are all operations that we are going to perform on stack. Now in this session we will be discussing how a stack is represented by using arrays. Right? We will be having some doubt that array has some disadvantage, like memory wastage problem or memory overflow problem is there in case of arrays. But even though while we are implementing this stack or representing stack by using arrays concept, that what you will be having some question. Let's see, arrays is one concept which is there in the programming, and with the help of that we'll be implementing an outside concept, a generalized concept, that is stack. And we know that we have some problems are there when we implement any concept or any method by using arrays concept, we'll be facing memory issues. Okay. But we need to know how to implement that by using arrays. And at the same time, in order to overcome the problem that we faced what when stack is implemented by using arrays, and that problem can be overcome what when stack is implemented by using linked list. But we need to know how these things are going to be implemented. Okay, just let's see how we are going to implement stack by using arrays concept. A stack can be represented as an array. Every stack has a variable associated with it, which is used to point the topmost element of the stack. That means here there are two things are there. A stack can be represented as an array. That means if you take some array and that array we can consider as what? Stack. Along with that array, you can take some other variable, and generally we'll be taking the name of the variable as top, and that variable always points to the topmost element of the stack. Okay, so let's see how it is going to be done. See, you can see here we are taking one hash defined space max space file. Here max is one macro, and this was defined with the help of hash defined preprocessor directive. And where we are using this max means we are using this max at the time of declaring an array. That means in the space st of max. So this max is macro. It's what symbolic constant, and wherever you are using max in the program, and that is replaced with a value as 5, because here we are taking max value as what? Right? So in the space, st of max means how we need to interpret that? We need to take that in the space st of 5. That means st of 5 means how much memory is going to be allocated, how many elements that we can store. We can store maximum of 5 elements, and the memory is going to be allocated as what? 5 into 2, 10 bytes, or 5 into 4, 20 bytes of memory is going to be allocated. And how the memory is going to be allocated? Sequentially, the memory is going to be allocated like this. Generally, we used to represent one-dimensional array in horizontal, but in this case, we are representing a one-dimensional array in vertical. The reason is that you can easily understood the concept of stack. That's the reason we are representing the stack in vertical. Like 5 blocks are there: 0, 1, 2, 3, 4. These are the indexes. 0, 1, 2, 3, 4 are the indexes that we have. And we are taking one more variable, that is top is initialized with what? -1. Here is the top that we have, and that is initialized with what? -1. And there is one reason for initializing top with what? -1. We always seen this kind of case when you are going to perform insertion operation, deletion operation. If you find the element, you are making the value of f as 1. And last we are checking the value of f is 1 or 0. If it is 0, we are giving some message, no element exists. Just like that, we are taking top variable as -1. If at all top is -1 means we can say that there are no elements in the stack. Your stack is what? Empty. Or we can say that your stack is what? Underflow. You will be having a question, what is an underflow condition for stack? Simply, when it is implemented by using arrays, simply you can say that if top equal to -1, then stack is empty, or stack is what? Underflow. Okay, this is how we are going to represent a stack by using arrays. Very simple, that will be declaring one dimensional array, and that array itself we are saying as what? Stack. and we are representing that in vertical form in order to make you the concept very clear. Okay, so this is how we are going to perform. We are going to represent stack by using what? Arrays. Now, what are all operations that we can perform on stack? Basically, we can perform what four operations? One is push, which adds an element on the top of the stack. Pop removes an element from the top of the stack. Peek returns the value of topmost element of the stack. Apart from this three, we have one more operation, that is traversing or display, which is used to give you the list of elements that are there on the stack. Okay, these are the four operations that we are going to perform. That means if you are implementing stack by using arrays concept means, then what your program consists of what? Four functions plus one more function, that is exit function. Right? So like this, we are going to implement, and we'll be seeing the push operation clearly and what is the logic for push operation, and pop operation and what's the logic for pop operation, and peek, what's the logic for peek, display, what's the logic for display. All these operations will be discussing along with their logic and diagrammatic representations. Now let us enter into the push operation, and we need to follow some steps in order to push or insert an element into the stack. The first step is we need to check whether the stack is full or not. Why I am saying this? Because we are implementing stack by using arrays. In case of arrays, we are in a position to store only limited number of elements. There I taken, if you can observe here, in this slide I taken int space st of max, means the value of max is what? 5. That means in this st, maximum how many elements I can store? 5 elements I can store in this st. Right? So that's the reason, if the user, I already stored 5 elements, again I would like to store one more element. Is it possible? Not possible. So in that case, I need to give some message to the user that your stack is full. Okay, and how to frame the condition for this, I will be explaining you that. Right? So if stack is full, then what we need to do is we need to print some message that stack is full, or we can print a message called stack is full. Right? You might be getting a question, what is overflow, underflow condition for stack? Right? So underflow condition we already discussed, that if top equal to -1, then your stack is what? Underflow, or stack is empty. Right? Overflow condition I will be discussing with you when it is implemented by using arrays concept. Right? So if your stack is not full, then what we need to do is increment the top variable and store the value in st of top. And how we are going to implement the top variable, and all these things I will be explaining with you. Right? Now let us see. Let us see the first step. What the first step is saying? Check whether the stack is full or not. Right? So how to check it? How to check it? Right? So if st array is filled with all elements, then stack is full. Otherwise, it is empty. That means this is an st array, and this array, all the elements, all the blocks has been filled with the elements, means then we can say that stack is what? Full. Otherwise, stack is what? Empty. Otherwise, stack is what? Empty. And one more thing is that if your top variable, this one, is pointing to the last element index, that means if complete stack is full, means this last element index becomes what? 4. That means automatically your top is going to become what? 4. That means if your top is pointing, or if your top value is the last element index value, then we can say that stack is what? Overflow. Stack is what? Full. See here, I am going to frame a condition in such a way that top is equal to max minus 1. Again, question is why you are taking max minus 1. So we are taken, when we are declaring this array, in the space st of max, means max value is what here? 5. Right? So in that case, what's the last element index becomes 4. That means 5 minus 1 gives us what? 4. So that's the reason I'm taking one condition that if top value is equal to max minus 1, max means what? 5. 5 minus 1, that gives us what? The last element index. If your top value is already 4, then it's not possible to insert an element into the stack. It's not possible to insert an element into the stack. Right? So if stack is not full, then there is a provision for us to insert some elements. So as per the current situation, stack is not full, stack is empty. Now I would like to insert some elements into the stack. And I would like to insert some elements such as 10, 20, 30, 40, 50 into the stack. And I would like to insert one more element, that is 60, and let's see whether sixth element is possible to insert the stack or not. Right? So this was the actual logic that we are going to follow when you want to perform insertion operation or push operation onto the stack. Try to observe here what we are taken, that top is equal to max minus 1 we are taken. That means when you want to insert some element into the stack, and first and foremost thing what we need to do is there any chance to place the element or not? If there is a chance, then we will place it. If there is no chance, then directly we need to use some message that stack is full when you are going to perform insertion operation or push operation. That's the reason I am taking one condition that if top equal to max minus 1. If your top is max minus 1, then if part is going to be executed. If top is not max minus 1, then it comes to what? Else part. Right? Just see here, what is the status of array here? The array is what? Empty. And your top is what? Minus 1. Your top is what? Minus 1. Your array is what? Empty. Right? I am going to check the condition here. Minus 1 is equal to max minus 1. Max minus 1 means, remember, it is 4. So minus 1 is equal to 4 means condition is false. If that condition is false means, then what happens? It doesn't execute this if part. It goes with what? Else part. Okay. In else part, what happened here is they increased the top variable by 1. You can see here in the previous slide, the value of top is minus 1. In the next slide, the value of top is what? 0. And push of 10 means 10 has been placed here with the help of this instruction, like st of top. Top means the value of top is 0, st of 0 is assigned with what? N. That means in this block st array, 0th element is going to be what? 10. And your top value is what? 0. So that's the reason the top is pointing to what? This 10 element. Okay, this is how we are going to perform push operation. That means this is how we inserted first element into the stack. Right now, the user wants to insert or push one more element into the stack. That means push of 20. Now this 20 has been stored in N, and this condition is going to be evaluated. The top value is what here now? 0 is equal to max minus 1 means 4. 0 equal to max minus 1 means condition is false here. If condition false means it goes with what? Else part. It goes with what? Else part. In else part, what we are taking again? Top plus plus. We are increasing top by 1. We are increasing top by 1. That means top becomes, up here top value is what? 0. Now top has become 1. Top is 0. Now top has become what? 1. After becoming 1, we are going with this instruction st of top means st of top means st of 1 assigned with what? N. So n value already I said that 20, and 20 has been placed as a first index the st array, and your top value is what? 1. Here. Now we inserted second element. Still, how many elements we can insert into the stack? Still, we can insert what? 3 elements into the stack. Right. So now I am going to insert one more element, that is push of 30, and I am checking condition top equal to max minus 1 means the value of top here is what? 1, because 2 elements are there, 0 and 1 2 indexes elements are there, and 1 is equal to 4 means condition false. It goes with what? Else part. It goes with else part. Top plus plus means the value of top from 1. Previously you can observe 1, and from 1 it has become 2, and we place 30 at second index with the help of this instruction. St of top means st of 2 assigned with what? N. N value is 30, and we are placing that 30 into the stack. Now still 2 more elements we can insert. So now what I am doing is, again I am going to call push. Push of 40 means this time the value of n is what? 40, and I am checking the condition. Top equal to max minus 1 means what's the value of top here? 2. 2 is equal to 4 means condition is false. Condition false means it goes with what? Else part. In else part, again top plus plus. Actually, what's the value of top on previous slide? It is 2. Top plus plus means it becomes 3, and st of 3 assigned with n means the value of n is what? 40, and that 40 has been placed into the stack. Okay. Now again I am going to call push function. This time I am giving the value as what? 50. And the 50 has been stored in n, and we are checking the condition. What is that condition? Top equal to max minus 1 means 3 equal to max minus 1, condition is false. Max minus 1 value is 4. 3 equal to 4 means condition is false. It doesn't enter into the if part. It goes with what? Else part. Right? In else part, again top plus plus means top value is what? 4. Now it becomes what? 5. Now it becomes what? So top value is, previously top value is what? 3. Now it becomes what? 4. And we are placing 50 at what? 4 index. Right? Now again I would like to call this what? Push function. Push off 60, the value of n becomes what? 16. Top equal to max minus 1 means what's the value of top? 4. 4 equal to 4 means condition is true. And it prints the message that stack is full. Stack is full. That means we are not in a position to insert some other elements into the stack. Right? So some other elements into the stack. Right? So top variable is pointing to the last element index of ST. Then your stack is what? Full. That is what stack overflow condition or full condition. Whenever stack is implemented by using arrays, we can store only limited number of elements. We cannot store n number of elements as per the requirement of the user. We are not in a position to store the elements like that. Okay, so this is how we are going to perform push operation on stack, and now we'll be discussing how to perform pop operation on stack in coming session. I hope everyone understood it. Thank you.